On this type of equation, we need to first get rid of the fraction. Or we could move the 8 away from the y first. Either way will work. Maybe we should just move the 8 first. So that would look like this. I could add 8 to both sides of the equation. Minus 8 plus 8, those cancel. And on the left side, I'm left with 15. On the right side, y over 3. Now what do we do? Well, since y is being divided by 3, we do the opposite, which is multiply by 3. Sorry about that. Having a little difficulty there. So the 3's cancel on the right side of the equation, leaving y. And on the left side, 3 times 15 is 45. And that would be one good way of doing it. Here's a similar one. Let's start by adding 3.1 to both sides of the equation. And u over 2 is equal to negative 6.4 and now I just need to multiply both sides of the equation by 2. 2's cancel on the left, and on the right side we get negative 12.8. And so clearly it's very similar to the preceding topic we just did. On this one, we don't have fractions, so that's nice. However, we do notice that the variable appears in more than one place. So just like the keymaster and the gatekeeper in Ghostbusters, we need to get these two together. So we can either subtract 9v from both sides, in which case the v's on the left side of the equation will disappear, or we can subtract 5v from both sides, in which case the v's on the right side of the equation will disappear. I'll do it that way. It doesn't matter which way I do it. On the left side, 9v minus 5v is 4v, and the minus 30 and the negative 6 are unaffected. Notice this is a negative 6, not just positive 6. So now I will add 30 to both sides. And those guys cancel, and I get 4v equals 24, not 36, 24. Then I will divide both sides by 4 because that's the opposite of what's happening to the variable. It's being multiplied by 4. And the 4's cancel. And 24 divided by 4 is 6. And the problem is complete. In this problem, I need to first extract the variables from the parentheses. As long as the variable is inside the parentheses, I cannot solve for it. So I will begin by multiplying the negative 2 through to the w and the 1 on the left side of the equation, yielding negative 2w minus 2. And on the right side of the equation, I'll multiply the negative 2 through the parentheses to the 6w and the minus 3, yielding negative 12w plus 6. And then the plus 4w on the end just stays there. The parentheses have been eliminated. Now let's combine like terms. On the left side of the equation, there are no like terms. But on the right side of the equation, there is the negative 12w and the 4w, which combine to make negative 8w. And the plus 6 follows along without a change. Now, this problem is just like the last one we did. So I will add 8w to both sides because I just like ending up with everything, with the variable on the left side of the equation. Negative 2w plus 8w is 6w minus 2, and the 6 on the right side of the equation don't change yet. Now I will add 2 to both sides, yielding 6w equals 8. And then I will divide both sides by 6 so that I end up with w equals 4/3, or 1 1/3 if you like. And that's it. Once again, notice that once I got to this point right here, it was just like the last problem. On this one, we want to get the variables on the same side of the equation, of course. So I will subtract 11y over 10 from both sides. This isn't the only way to do this one or to start it, but it works well. That leaves me negative 2 on the left side of the equation. And on the right side, I have 9y over 8 minus 11y over 10. Now, I need to get rid of these denominators. I don't want to be working with fractions. This next step, I could have done right at the beginning of the problem, but I chose not to. That next step is multiplying both sides by the least common denominator. So first I need to know what that least common denominator is. It would be the smallest number that both denominators can divide into. Well, I'll just take 10, for example. I could use 8 instead. 10 times 1 is 10. Can they both divide into 10? No. 10 times 2 is 20. Can both numbers divide into 20? No. Can they both divide into 30? No. Can they both divide into 10 times 4? Yes. Therefore, the least common denominator is going to be 40. So that is what we will multiply both sides of the equation by. So I'll multiply the right side by 40, and I'll multiply the left side by 40. So on the left side, I get negative 80. That's the easy one. And on the right side, I get 9y over 8 times 40 minus 11y over 10 times 40. Now I can cancel certain things. Because we multiply both sides by the least common denominator, all denominators should now cancel away. 8 divides into 8 once and into 40 5 times. 10 divides into 10 once and into 40 4 times. So the equation simplifies on the right side to 9y times 5 is 45y And 11y times 4 is 44y. (45y minus 44y is just y. So problem is done. And that's it. A little tricky, but certainly not beyond you because you guys are really smart. Last one. On this one, we are given an equation, and we are to determine if there is no answer for it, or if there is just a single answer like normal, or if all numbers are a solution. For example, if you end up with an answer like x equals x, then it doesn't matter what you plug in for one x, you'll plug it in for both, and therefore it will be all real solutions, or all real numbers are solutions. Contrast that with when you end up with a problem like 3 plus x equals 4 plus x, and you subtract x from both sides in an attempt to get the x's together, but then you just end up with 3 equals 4, which is never true, in which case you would say no solution. So let's see how these go. For the first equation, just like we learned before, we need to multiply away the parentheses. So we get negative 6u minus 6 plus 8u equals 2u minus 6. Combining like terms, I get 2u minus 6 equals 2u minus 6. If I add 6 to both sides, I get 2u equals 2u, and if I divide both sides by 2, I get u equals u. So it doesn't matter what I plug in for u, the variable, I will plug it in on both sides, and therefore I will get all real numbers are solutions. A slightly different way to finish that problem would have been to subtract 2u from both sides to get 0 equals 0. Well, 0 equals 0 is always true, no matter what you plug in for the variable. Therefore, we again confirm that the answer is all real numbers are solutions. What about the second problem? On that one, we start off the same way by multiplying away the parentheses so that we get 3v plus 6 plus v equals 4v minus 4 plus 9. Combining like terms, we get 4v plus 6 equals 4v plus 5. We subtract 4v from both sides to try to get the v's together, and we get an obviously false statement, 6 equals 5. Therefore, since the variables completely went away, it doesn't matter what we plug in for the variable. The left and right side of the equation will never be equal, and therefore the answer is no solution.